Welcome to the Omar Alayli podcast, your go-to podcast for exploring the diverse fields driving space exploration and technology. I'm your host, Omar Alayli, and today I'm thrilled to be joined by Sandra Haeuplik-Meusburger. Sandra is a senior lecturer at the University of Technology Vienna. Her research focuses on habitability design in extreme environments. She has authored 3 influential books on space architecture and space habitats. One of them, Architecture for Astronauts, was my personal gateway to the field of space architecture. Sandra has also published many scientific papers and won prizes in the field of aerospace design and research. Sandra, thank you so much for taking the time to be here today.
Hello, Omar. Thank you for inviting me. I'm looking forward to it.
Great. Sandra, could you share a story of how you first encountered or got introduced to space architecture? Did you seek this field and what initially drew you to it?
I think I chose the field with a little roundabout because when I studied architecture, when I started to study architecture, my initial goal was to understand how we as architects can make spaces better so people can live well and work well. And during my studies, I was excited, learning more about cognitive maps and what materials can do and the perception of space. And towards the end of my studies, I started working in space architecture because I thought it was very interesting to research the most extreme environment in relation to the users in a habitat.
Mhm.
And eventually this turned into my thesis that I took at TU München with Professor Richard Horden. Um, and some year later, I was lucky that the thesis or some part of the thesis turned into my first book, Architecture for Astronauts, that you mentioned. Thank you.
Mhm. Okay, cool. Some of our listeners might not be familiar with the term space architecture. NASA sometimes gives the title of aerospace engineer, flight systems designer for people working on space habitat design and research. How do you define space architecture in your own words, and why is it, in your opinion, an essential field for future exploration?
Okay, let's start. Space architecture has already a definition. It's defined by the Space Architecture Technical Committee as the theory and practice of architecture in outer space, extraterrestrial architecture. The definition was then further expanded in that it also includes the architecture in extreme environments or for extreme conditions in living on Earth. That includes polar bases, but also underwater habitats. The Space Architecture Technical Committee was founded, I think 25 years ago. And this definition comes from the first meeting of this Space Architecture Committee in 2002 in Houston. Yes, that's 23 years ago. I was lucky that I was part of this,
Mhm.
and it has also influenced my way of thinking what space architecture can do. For me, space architecture is a field in architecture.
Mhm.
It's interesting for architects, especially for educating architects, because you have to look at certain themes more in detail. For example, in space architecture, we are working with a very extreme, hostile environment, and it's very important to take that into account. That is probably why it's often related to space engineering, because the architectural conditions demand a very high and precise solution from a technical perspective.
Mhm.
As in outer space, you cannot live without the habitat. And what we as space architects can bring into is now that it goes towards long-term living.
Mhm.
So a machine, the technical solution was fine, to keep astronauts alive and to complete the mission. But the longer the mission takes, The more people are living and working in this environment, the more important it is to include architects and make this place a space where people can work effectively together.
Sandra, you've been in this field, you've dedicated a couple of decades for this field of space architecture. What personal values or motivations have sustained your passion for this field in such a specialized field like space architecture?
Well, for me, it's super interesting because it's actually learning about ourselves
Hmm.
a lot. Learning from extreme conditions is fruitful for my work on Earth as well.
Hmm.
You know, from my own architectural office, I have a lot of lessons learned from the experiences that the astronauts have made in space. Um, so it's extremely fruitful on one side from a practical point of view.
Hmm.
On the other side, it's very exciting. Right now, we are really moving faster towards the goal to become a spacefaring nation, to have lunar bases and travel a bit further away from Earth. And this is exciting. So it has to do with dreams and vision, and I like the combination of science and fiction.
Yeah, space architecture is considered human centric. You agree, right? Um, However, space architecture doesn't have centuries of built-in heritage to learn from and build upon. In addition, the data we have comes from highly trained and extremely small pool of astronauts, 280 as of 2024. And those astronauts have operated in a space environment on short duration missions, averaging 3 to 9 months. How do you guide your students to work with such limited specialized data when designing for extraterrestrial habitats?
Yeah, first of all, I would say I hope it's human oriented. Even sometimes on Earth, I'm not sure if Earth architecture is human focused. So that is very important to realize as an architect that when we build and what we build, it's for humans,
Hmm.
living environments, working environments. And in that, we have to carefully think of what we do in these environments. So the human activities approach is very strong in my teaching and my work, also in relation to the environment, of course. And we can learn a lot from the experiences in space, as you said,
Hmm.
but we can also learn a lot from the experiences made in other extreme environments on Earth. And there are a lot of case studies or a lot of lessons learned from habitats in the polar regions. A lot
Okay.
more people have lived and worked in those environments. And one thing that is interesting in those environments is that in those environments, people live that are not especially trained, like astronauts.
Hmm. Talking about the polar region, we have a large community of scientists living in the polar region under extreme environments. What are one or two key lessons that architects, particularly those designing habitats for extreme environments like space architects, can learn from the experiences of scientists living in those isolated polar research communities?
There are actually a few. I mean, the way I was working on this field was first to look at what's different, what's different when designing in space, what's different in space architecture than on architecture on Earth. But from these lessons learned, I realized that we have something in common, and I realized that we as humans are not changing too much when we move from one environment to the other.
Okay.
So we have the similar expectations to sleeping, for example. We have similar expectations to how we want to work. Um, but the solutions have to change because the environment has other restraints.
Hmm.
So in our latest book that I did with Cheryl Bishop is a psychologist,
Hmm.
and she has a huge experience on psychological studies in Antarctica, with people cruise in Antarctica,
Hmm.
from a human point of view. So in the book, we threw our experiences and thoughts together,
Hmm.
and we have come up with a few themes that are important for all environments. So, for example, privacy is very important in any environment, uh, as is social space.
Okay.
This sounds like an easy solution, or this sounds like a solution that is evident,
Hmm.
but in reality, it's very hard to integrate spaces where people can retract or withdraw from the group, and at the same time have spaces where the whole group can meet,
Hmm.
because we have so high limitations of
Okay.
volume and weight.
And okay, a follow up question. Have you or anybody considered adjusting those internalized habits? Like, we know in the International Space Station, they work on 8-hour shifts. Is this something space explorers are going to have to complement their exploration in space with by also allowing themselves to change and adapt their daily habits? Or are we just designing for the elite astronauts that can easily accommodate those kinds of changes?
Yeah, you're talking about two things that are both very important. The first one is adaptability, flexibility. That is vital if you want to have a long term, sustainable habitat in space.
Hmm.
The reason for that is that the space station is inhabited by variety of crews from different cultures that are not yet known or assigned to. So
Hmm.
you are planning for someone that you don't know.
Hmm.
That means you have to integrate some adjustability.
Hmm.
What was evident or is evident in all the images and movies you see is that crew quarters, we talked about it, the personal space is where people have their storage, their private communications. The astronauts have always decorated these crew quarters
Hmm.
for personal reasons. So it's very important that the user can move in and adapt to his or her conveniences.
Okay. Just for reference, the book that you're referring to is the Space Habitats and Habitability, right?
Yes.
Okay, so aerospace industry in general has often treated the human factors as a design parameter alongside mass, volume, systems, subsystems, and safety. Architects here on Earth, on the other hand, prioritize, hopefully, like we said before, the quality of life of the people who use their structures. How do you reconcile those two mindsets in your teaching? What do you believe your students uniquely bring to the table as designers and architects of future habitats? Or what do you hope your students will uniquely bring to that table?
We had a lecture last week by Luca Pamitano, and he
Hmm.
talked about his experiences from. He talked about space architecture. He talked about design from a user point of view,
Hmm.
and it was very interesting because he essentially said that it has to be functional.
Hmm.
And this is what I have learned from all the astronauts I have interviewed too, that the architecture, the provided equipment, the facilities should make the life of the astronauts easier,
Hmm.
not more difficult.
Okay.
Uh, and then, in addition, comes the adaptation to their needs.
Hmm.
So there is, I think it's a typical architectural task to use space very efficiently. On Earth, it's not needed so much because we can have, when you have a house, for example, you can have a kitchen, a room where you eat, a room where you play. Everyone has a private bedroom, and then you have
Hmm.
some storage spaces. In space, because you have the limited volume, you
Hmm.
cannot have a room, a space for every activity. So you have to think more about how the space is used. And sometimes activities overlap.
Hmm.
And this has to be carefully planned in order not to make it awkward.
Okay. Yeah, the thing about the International Space Station and space stations, it's a legacy structure that has been designed in the 80s, and now we're just trying to adapt it to the needs of the astronauts. But now we're working on designing new habitats, and we can learn from those lessons learned. So, looking back at early conceptual designs for lunar bases versus the latest research on lunar habitats, like the NASA's lunar safe haven concept, the 2022 concept, where do you see the biggest shifts in assumptions or priorities? And how do you incorporate these lessons in your classwork?
I think from the concept point of view, not too much has changed. A lot has been changed because of technical developments.
Hmm.
We have larger rockets. We have 3D printing, 3D sintering
Hmm.
technology, but basically, the idea is to have habitats that are protected from radiation,
Hmm.
from micrometeorites, and that can be adjusted to future mission goals.
Hmm.
The only thing that I am observing at the moment is that the visions from the architects are quite far away from the actual reality what is being built.
Okay.
What we can see now, for
And what,
example,
why is that?
I don't know why it is that. It's because we are reusing uh, living space, for example, gets smaller, not larger,
Hmm.
which is a requirement actually if you want to have long term solutions,
Hmm.
to have larger living space.
Hmm.
Um, we can also observe this on Earth when we talk about smart housing or compact living. Very often, habitats or living compounds are smaller,
Hmm.
but not necessarily better designed.
Hmm.
And I would say space or size is not always an indicator for quality,
Hmm.
but certainly you have to have a better design for smaller spaces.
Okay. Off-world habitat concepts are leaning towards, I find, robotic construction. How do you teach students to adapt their designs and thinking when humans might not even be on site for the building?
Yes, it's a very important aspect how to integrate new technology. And I have to say, it's a big topic of discussion at architectural school.
Hmm.
And it reminds me to the 70s because also today we have the group that wants to preserve, to sustain, to use what is local materials, and on the other side you have people that want to invent new materials, technologies, develop sophisticated solutions. And we had similar discussions in the 70s when the
Hmm.
sustainability topic arose. You know, when the first image of the Earth was made,
Hmm.
and this image combined those two topics. It combined the wish to preserve what we have,
Hmm.
the tradition, and the modern technology. And I see it the same way that we have to use the new technology. We should. We have to be careful. So, I mean, a lot of technologies like AI that are wonderful tools if you know how to use them. And it's when I'm teaching, I like to challenge the students to think creatively how they could use these two worlds together. But the goal is always to make the life for human better.
Okay, let's move into a away from the moon, maybe a little bit towards Mars. China is committed to a Mars mission. And as a response, Elon Musk and the Trump administration, as we heard lately, are shifting their attention to Mars as well, while the Artemis lunar program is still suffering delays. We, the space community, all know that before living on Mars, we need to survive the trip there, right? However, since nuclear powered propulsion is still in its infancy, using conventional propulsion and the Hohmann orbital transfer, it would take 9 months for a crewed spaceship to reach Mars. What do you see the critical human centered design responsibilities for future Mars transport space architects, especially as mission lengths extend and physical, psychological, and environmental factors become more significant?
Yeah, with Mars, there are a few more challenges to meet. First of all, as you said, it's the long way, but from a physical point of view, one of the big issues is radiation,
Hmm.
because it's not clear yet how you could protect the crew on the way to Mars to make sure they arrive there. Not the question they come back, that's the next question, but just to make sure they arrive there.
Hmm.
Then you travel in microgravity,
Hmm.
and when you land, you have gravity. So that's another issue. How can you make sure that after such a long term in microgravity, that the crew is instantly prepared to work and operate in a gravity environment? Another aspect from psychological point of view is that while it's super exciting, new, and very dangerous and challenging to go to Mars, the
Hmm.
journey itself will be very boring because
Okay.
there's nothing to see, not a lot to do. So for this, you have to plan for. And in addition, you have the crew differences
Hmm.
on the journey. So
Yeah.
there are a lot of ideas, concepts.
Hmm.
For example, hibernation, like people would sleep and then wake up.
Hmm.
There are also ideas of bioengineering the human body.
Hmm.
So a lot of ideas that need to go a bit further from the idea into some concept developments or testing,
Okay.
for which the moon would be a very good environment. Also, the orbit for some cases, a new space station or new space stations are being developed for commercial and scientific uses. So a lot of testing has to take place, I think, before we can go to Mars.
Jump
Well,
to Mars.
not the thing is, it's not only Artemis, it's Chinese have their own missions to the
Hmm.
moon. And
Hmm.
they plan to land there 2026, and I think with a human in 2028 or 2030s.
Hmm.
Then we have other nations, and I guess the moon will always be interesting.
Okay.
And if it's interesting, not only because of a political interest, I think it's even better.
Okay. As we see SpaceX, Blue Origin, Axiom, and other commercial players are taking on roles in orbital and lunar habitat design and development, do you think private companies can truly match and make breakthroughs in what was once the bread and butter of national agencies and institution led missions?
Yeah, I think they can, and I think they do. They did already. So there is this big advancement in
Hmm.
technologies. For sure, is related because private players are coming into play.
Yeah, but they're coming in also with the let's do it quickly and fast. Do you think that's something we should look for, or?
I mean, first of all, it's not that quick, I guess. Things would take the time to test.
Hmm.
And in terms of quality, for example, if it's related to tourism, it may even push the interior quality because the expectations of the customers
Hmm.
are higher than the ones that are, like personnel, like trained astronaut personnel, I would guess. So people that are paying for a certain service
Hmm.
expect something from it. For example, windows where they can view the Earth or view something else. Um, and at the same time, you have to plan more carefully in order to have a safe habitat. Because if you have inhabitants that are not trained for a half a year or a year, you have to make sure that the habitat is safe and
Okay.
intuitive to use.
Lately, we've on the news in the past couple of weeks, we've been hearing that they found when they finally we retrieved samples from an asteroid, and they found the building blocks of DNA, or like the amino acids. How do we, as a community of space architects, or in general in space, have to deal with intruding and bringing our stuff into a place that could have its own life ecosystem? Do you
Uh,
consider this?
yes, yes, it's very important. So first of all, I think it's exciting to look for life
Hmm.
wherever else and to learn, because this also means that we learn more about ourselves, where we come
Hmm.
from, and what is there. And there is really a very strict procedure when we go to other planets, especially to Mars,
Hmm.
because there is a procedure that we should not interact with the environment, in that we exchange particles.
Hmm.
Otherwise, we can ruin the whole mission.
Hmm.
Because if we go there and we bring our life there, how can we separate this from what we see or what we detect?
Okay.
So the the habitat itself is planned in order to be very closed.
Hmm.
Also, on the moon is a good example, because the moon has a sandy surface. It's
Hmm.
called a regolith, that is very dangerous for human beings. It's radioactive, it's very fine, it's sharp, and basically, we do not want to have this dust in the habitat.
Okay.
And that is why there are really engineering efforts. It's called, for example, a suit port, uh, or a dust lock, in
Hmm.
order to keep this dust outside. And so this technology is matured, has matured over the years.
Great. One more question: if what which proponent of of a habitat model are you more into, or believe have more feasibility to happen? Is it a solid structure, or is it inflatables?
I think there's not either or, because in addition, we have in situ resource utilization,
Hmm.
which is their topic at the moment.
Hmm.
The thing with regular modules is we have done that, we know how they behave, they can be constructed very fast, calculated, tested on ground. So I think the cylindrical habitats, as we have them on the space station, as we will have them on the Lunar Gateway, we will probably also see on the moon,
Hmm.
because we can make them the easiest.
Okay.
Then we have inflatable habitats, which has been tested effectively
Hmm.
in the space environment. We have
Hmm.
the Bigelow module,
Yeah, and now Sierra Space.
yes, and Sierra Space, uh, but they are more complex. And it turned out that the weight of those modules is also not, it's not light.
Hmm. Okay.
So what I have learned from other people from industry is that you need a certain volume,
Hmm.
so they make sense. It doesn't make sense if you have only a small volume
Okay.
uh, for the transport. And then we have in situ resource utilization, which is based on the first two.
Okay.
Because before you build something there, you have to have something there. You need machinery, you need something like a temporary habitat
Hmm.
or robots. And but this would be the ultimate goal because that
Okay.
means you don't have to bring too much from Earth.
Okay.
Also, in when you go to Mars, the idea is that first you construct everything you can, and then you send humans.
Great. Um, in your view, which core principles or skill sets are absolutely essential for students who aspire to become space architects?
Um, you have to learn. You have to be interested in science and techniques, I think,
Hmm.
and also have a feeling for humans. It is a very interdisciplinary field. Certainly, regular architecture study, I think, is not enough. You need more knowledge because the environment is so hard and different.
Hmm.
So you need to know a lot about the effects from radiation or some physics,
Hmm.
how the environment affects the human and the construction. Um, I think it would be good to have an open ear for new technologies or new developments because space architecture is a field that is so open that as a space architect, as a space engineer, as a space company, you are actually building the road.
Hmm.
You know, it's not a road that you can go and pick things and choose. You are actually saying or showing which way to go.
Hmm.
So you have to be brave to make decisions, curious, and also not to be afraid to not to lose or how to, yeah, because you will not succeed probably the first attempt.
Okay.
Uh,
Okay. A thick
I think
skin.
yes, you need a thick skin, a hard belief, similar like when you work on a thesis. You know,
Okay.
when you work on a PhD,
Hmm.
even if it's your topic, it's hard at sometimes,
Hmm.
and you need the energy to go through.
And what you start is almost never what you finish with.
Yes, and you need this creativity, yeah, the
Yeah.
creativity to deal with situations that are new.
Okay. Um, how do you encourage students and also professionals to think about sustainability and broader societal impact of space architecture?
Um, the more I know about history, the more I have learned that space is, and also when we look now at our world, space is a place where we can communicate with each other on a level that is not too political.
Okay.
In space, you know, Russian and Americans work together. On the
Hmm.
moon, maybe Chinese and US and Russians and also other people from other nations will work together. I can also observe this on an educational level because I work with US students, I work with European students, but
Hmm.
I also work with Chinese students. And they work together, and it's very good that people get to know each other and learn about each other's cultures.
Okay.
So
Cool.
I think it's very important for us as people on Earth
Hmm.
to find a common sense, and space is one. We
Okay.
can only go to space together. No nation can do it alone, no company can do it alone. And while we learn how to do it, I hope we learn it,
Hmm.
uh, we learn to be a better community on Earth, I think. So,
You mentioned in the early in the beginning of the interview about transfer of knowledge from science fiction. Let me ask you a question. Science fiction often imagines futures of humans not just inhabiting but thriving on our moon, Mars, Jupiter's moons, and other places in our solar system. How do you use science fiction narratives in your class or research, and where do you see the boundary between inspiration and reality?
Um, for example, Jules Verne
Hmm.
is one of the most famous science fiction authors, or the ones that foresee or envision the lunar mission.
Hmm.
And it's surprising that the best science fiction authors have incorporated the physics very well.
Hmm.
So they were not just dreaming of something, but their dreams were based on a logic. And we know that Jules Verne had also, has foreseen Florida, the rocket, the drawings, microgravity, how they would move,
Hmm.
long before there was anyone in space, or long before people would even recognize that it's possible to leave Earth.
Hmm.
And there are other examples. And what we do at the university, for example, this semester, we have another design studio on large space station structures.
Hmm.
And we will have a workshop with a physicist.
Okay.
In that, we had this before, in that we take some stories, for example, from Arthur C. Clarke, and we will calculate and see if it's possible. So we will really calculate the diameter of a rotating habitat, for
Yeah,
example,
from
or what is
Rendezvous
the,
with Rama.
yes, Rama is one of the reading, the literature we propose to the
Yes,
students.
one of my favorite books. Okay. Yeah,
Great.
sorry,
So
continue.
come and visit us.
Sorry, yeah, you were saying?
Come and visit us.
Yeah, yeah, sure, we'll do. Hopefully. So we're saying about the books, that program.
No, no, Rama is one of the books
Yeah.
that I will suggest the students to read.
Okay. And then they will do exercises based on trying to
Yes, we
bring that.
will pick one example
Hmm.
because they have to get a feeling of the size of such a station and what
Hmm.
artificial gravity means in terms of design.
Okay.
And we will do this also that in terms of calculating. So, and for that, we have invited a physicist that also writes science fiction authors,
Hmm.
and it will be fun.
Oh, yeah, sounds like great. Um, okay, so in your paper, the designing human computer interaction systems for space exploration, I quote from it: "Keeping a human healthy, happy, and productive in space is one of the most challenging aspects of current space programs. When designing habitats for long duration missions, how do you integrate human factors, mental health, social dynamics, daily routines into architectural decisions that you make for the habitat?"
There are many levels how to deal with that.
Hmm.
Of course, you need, but okay, let's start from an architectural point of view. It starts with the architecture of the habitat.
Hmm.
Because as the architecture, the habitat is a built environment.
Hmm.
It has an enclosure, it has physical walls and floors, and with that, it either enables the people inside to do something or disables.
Okay.
So it is very important that you have supporting architecture for the
Hmm.
crew that, for example, supports all the crew members uh, to live together and do something meaningful together. And
Okay.
for that, you need actual space.
Okay.
You also need actual space for each of them to withdraw and uh, get away from the crew. This includes insulation,
Hmm.
this includes visual exclusion.
Okay.
And this you have to plan for. And then you need an additional typology of spaces
Hmm.
where two or three can meet and talk about others as a kind of psychological hygiene. You know, when we we work on Earth. We go
Mm-hmm.
to an office and then we go home.
Mm-hmm.
At home, we can talk about the people in the office with our partner.
Yeah.
And then we feel better, we can
Mhm.
share stories. And this is psychological hygiene.
Okay.
In space, where the crew, the working crew, and the social crew is the same, it's more challenging.
Mm-hmm.
So you need also these in between spaces, otherwise, you are exploding from
Okay.
a feeling point of view, from an emotional point of view. And that's interesting that some emotional requirements or
Mm-hmm.
behavioral requirements are very related to built space.
What do you see as the most pressing challenges facing space architecture today?
Now that we talked about it, I think it starts at the very beginning, from the
Okay.
from the conceptualization and designing of a habitat.
Mm-hmm.
Because if you start wrong, you will end wrong. We
Okay.
need at the very beginning an interdisciplinary approach how to design that.
Mm-hmm.
We have that on Earth.
Mm-hmm.
Usually, architects have a, a leading role, a guiding role to include different professions.
Mm-hmm.
Building physics and structural engineers. In large projects, it's usually the architect that brings all those disciplines together.
Okay.
And in space, it's very engineering oriented still.
Mm-hmm.
So probably also because it starts at university. Also on the university level, we need more interdisciplinary exchange with students. While they're learning how to solve a problem, it's good to see other methods
Okay.
to learn from other professions.
Okay. I completely agree. However, I also see some burden that needs to be uh, the gravity of our work needs to be translated to national agencies and maybe scientific communities to introduce space architecture in the same capacity that architects operate here on Earth. Because it feels to me that space architecture tends to become like an afterthought sometimes.
Yes, I agree, totally agree. It has to be, well, I think two sides. We as architects or space architects have to show people that we can make a difference. I think with the experiences from astronauts, we can do this.
Okay.
And then, of course, the decision makers have to see the value.
Okay.
For example, when we look at simulation habitats, um, there is no simulation habitat that is adaptable. You had in Cologne, you said you are from Cologne.
Hmm.
For many years, people in Cologne have been working on the Flex Hub.
Yeah.
The concept to have a habitat that can be adapted in order to test different missions with
Hmm.
different crews for different lengths and different activities. But up to now, it's still not here.
Okay.
And I think this would be important, or it would be a more ergonomic or more quicker way to have results.
Okay. Um, so how does your work and the field of space architecture at large potentially benefit life on Earth? Because that's a question we all are always asked. We're spending so much money on space programs, and we could spend it here. So
Okay, first of all, money that is spent for space is spent on Earth.
okay.
So it's not somewhere in an extraterrestrial habitat, piling up.
Hmm.
It's actually money that is really working here on Earth.
Okay.
And it's this huge investment is also a motivator for education.
Hmm.
I think this works still.
Mhm.
Which brings me to our new MBA program.
Mhm.
At the TU Wien, we have initiated an MBA with exactly that goal, where we
Mhm.
can learn from these extreme environments and conditions
Mhm.
for making our life on Earth better.
Okay.
Because some of the issues are related.
Okay.
Sustainability, for example. In space, everyone is forced to make the most with the least resources.
Mhm.
And this idea or this concept of thinking can also help us find better solutions on Earth.
Mhm.
Um, it is we can also learn on a spatial and socio-spatial view from the conditions of the astronauts.
Mhm.
Cities, for example, are very dense places. You know,
Mhm.
there are challenges on Earth in dense places related to the population and build space. More
Okay.
people, less affordable space, and the to make spaces smaller is not of help.
Okay.
Now we have really to think of how we can house a number of people in a compact environment, but with the goal to have them living in a happy situation. Actually, you know,
Mhm.
we've seen in Corona or in COVID a lot of problems that have erased because of isolation, because of dense living conditions, and we can learn from that now for future planning.
Great. So, what advice would you give to students or professionals who are curious about space architecture but come from completely different fields like engineering, medicine, psychology, biology, or even the arts?
Okay, that's most easy. I would recommend them our MBA. our our MBA is space architecture and management,
Hmm.
and is not essentially uh, related to that people learn how to draw sections and drawings and the lunar base, but to get a big picture of the field and work on a management level in order
Hmm.
to complement their ideas.
Okay.
But in general, everyone who wants to go into the space business, I would suggest them to go to the conferences, to meet people. It's very important to meet people, interact, and network.
Hmm.
Uh, to read a lot, even try to have some internships when you are
Hmm.
younger. And it's also good to have some kind of a specialization.
Okay. Um, Finally, looking ahead, where do you see the extent of our space exploration 20 years from now, 2045, 2050?
Where would I see it? We would have a research station on the moon
Hmm.
that is international with regular transportation,
Hmm.
um, changing crews. Uh, we would have a space station in orbit that is an experimental space station in order to test different conditions, maybe different gravity conditions,
Okay.
that can be used for commercial activities, but also used for scientific activities. It would include an option that is maybe related to the work that the UN does, in that it allows guest visitors from nations that have no support yet to go to space, so
Hmm.
visiting scientists.
Okay.
Uh, and we would have research, probably robotic research on the Mars.
Before we wrap up, is there anything else you'd like to share with our audience?
Um, You mentioned the book Space Habitats and Habitability. I have just finished proofreading for the German version. The
Okay.
German version will be out in 2 months.
Okay, cool. Sandra, it's been great having you here. Thank you so much for sharing your insights and expertise.
Thank you, Omar. It was lovely talking to you.
To everyone listening, this is the Omar Alayli podcast. Thank you for joining us and keep exploring.